Hello. Under process scheduling, we discuss about what are the necessity of choosing one process among all the existing processes to have the balance between the objective of multi-programming and time-sharing systems. Now, we are just going to discuss about what are the different scheduling queues available. Now, look at this. So, we are having one queue called ready queue, one is wait queue. So here, this is the one queue. First is the ready queue, which contains the list of processes. It have the head and tail. The head points to the first process. Here it points to PCB7. So PCB7 is the first process in the ready queue. Then again, it again points to PCB2. Then afterwards, it doesn't point to anyone. But remember, the tail points to the last process. So it has a queue which has a head and tail. Head points to the first process in the queue. First process points to the second process. Second process points to the third process. Keep on going till the last process. The last process stops at the 11. Whereas the tail pointer directly points to the last process in the queue. So this ready queue contains the list of process available in the ready state. Similarly, we are having the wait state. I'm having another queue. It maintains the list of processes in the waiting state. We know that each process have its own information stored in PCB, process control block. So here each PCB is indexed here in the queue. Look at this. We have see this. We are having a new state. When the process is admitted, enters into the ready state. From ready state, may migrate to the waiting state. So this ready state and waiting state are having a lot of processes are in the queue. So that is maintained by a ready queue and wait queue. Why we are not having any queue in the running state? At a time, one core can have only one process at the same time. So that I am having a separate queue for ready queue and wait queue. Now let us see this. This is a queuing diagram representation of process scheduling. Now let us take this, correlate this diagram, process transition diagram, and here when a process is newly created, it enters into the ready state. Here is happening. It is enters into the ready state. Once it is entered, if it is allocated from ready state to the running state through the scheduler dispatcher, it is moved to the CPU. Once it is completed, it will be terminated and leave out of the queue. No problem. But what will happen? While a process is in execution, if there is an IO request arises, it will go to the IO wait queue and it is in the IO. So here, similarly, when in the time sharing system, when the time slice expire for the process has to automatically move back to the ready state so that the next process can continue. So here, the rectangle boxes indicates the queue wherever these are the resources, the circular resources, IO and CPU are resources. Similarly, when a process is active state, at that time it creates a child process. Then what happened? We already discussed when a child process is created, we can make it to the fork and it will make it to join. The child process, the parent process can wait till the child process terminates using the wait system call. So it is in the child termination wait queue. Once the child terminates, it moves to the ready queue. Similarly, when an IO interrupt occurs, when an external interrupt occurs, then it moves to the interrupt wait queue. So then it will move to the ready state. So these are the different possibilities. Here we are having an abstract movement of ready state to waiting state. Here we have a detailed statement of whenever there is a movement from a ready running state to the ready state and what are the in between queues that each process need to travel through for a successful completion of a process. So this is a queuing representation. It is better to have this process state transition diagram to map the concept to understand the how a process moves from the ready state to the running state. So next, after that, we are going to discuss about CPU scheduling. So here, so where comes the CPU scheduler? We already know that a process will migrate among the ready queue and wait queue throughout its lifetime. Now, what is the role of the CPU scheduler? The scheduler will select one process among the processes that are in the ready queue. So there are a lot of processes available in the ready queue. So out of which one will be picked up and moved to the CPU for running state. So that is the job of the CPU scheduler. It select one among the processes that are in the ready queue and allocate a CPU to one of them. And in addition to that, there is another intermediate form of scheduling called swapping. What it will do is it will remove a process from active, that is from a memory, and after some time, the later the same process can be reintroduced into memory and its execution can be continued where it left off. So we will learn about the swapping of processes in detail later on. So here it's called a swap in, swap out because a process that is currently in the running state is swapped out and another process from ready queue is swapped in. There is otherwise called as intermediate scheduler. Next we are having the context switch. So under context switch. So what is context switch? Switching the CPU core from another process requires performing a state save of a current process and state restore of different process. So here we discussed so far that there is a movement from ready state to running state. So when a process is moved to ready to running state, meanwhile, any process is moving from running state to ready state. The process state is to be stored. The old process state should be stored and the new process state will be maintained. So that is called saving the state of the current process and restoring the state of the different process is called context switch. So now let us take, I am having two processes P0 and P1. Each process has a PCB where the states are stored. Yes, of course, it is in the PCB. So each process maintains the PCB to keep track of its information. Now, this is what happened. When a process P0 is executing, suddenly when there is an interrupt or a system call occurs, then what happens? Then P0 becomes idle state and it will save the state of the PCB 0. It updates the state of the process P0 in PCB 0 and what happened? Then it will reload the state from PCB 1. It will start removing to the update. The memory will start executing the P1 based on PCB 1. It reloads the state from PCB 1 and now process P1 enters into the execution mode. So once P1 completes its job, then the P1 state is saved into the PCB1 and again it reloads the state from PCB0. Why I need to have this? Because I need to complete the job of P0. Otherwise, the processor may lose track of what is the current state of process P0. So there is a need for PCB should be updated then and there whenever there is a context switch. So what is context switch? Saving the state of the current state and reloading the state of the new state to be takeover. So switching the CPU requires context switch, saving the state of current process and restoring. It is a major and fundamental phenomenon with the context switch which helps you to achieve a better multiprogramming. So far we discussed about what is process scheduling and what are the different types of queues and what is context switching, why it is important. Thank you.